Next, we'll directly learn a simple machine learning model. Machine learning, as always, starts with the data. And our goal is using this data to learn some very powerful models, which can do some meaningful predictions. For example, data is often represented as X, the part of the data which we are giving model as input. I'm only going to take a very simple example. Let us say our data has only 3 points, 2, 4, and 6. And we want to learn some unknown function, which is the prediction, which is often represented as Y in the machine learning. I'm going to write this prediction, say it looks like something like this. We don't know what this function is. So it's the job of the model to learn this transformation T, such that when T is applied on X, we get Y. This transformation or this function, you can say it's many different notations, but we want to learn this transformation. As we see here, this data is quite simple. This is nothing but 2x plus 1. Actually, this transformation is a very simple line. Y is nothing but 2x plus 1, as you see here. I'm saying this is a line because we can represent, say, this data in the form of x and y line. This is our first model, so we are keeping it simple, but we'll slowly grow into more beautiful, complex models. The main basics will still stay the same. So for 2, we are, say, predicting point here, 4, and 6. And let us say these points are marked as 5, 9, and 13. So the goal of the model is to learn this line. And this, our first model, is called linear regression. Now let us look into the code. Next, we will again continue from the first lecture and use Google Colab for our coding. In this way, you don't have to install anything on your laptop. You can go to Colab link directly as I showed you. And let me open a notebook. Let us look into the second lecture directly now with coding part. First cell of this notebook is defining variables, x and y. X is an integer, y is a float. We are also doing a summation operation between x and y, and we are showing the results. If you run this cell using shift enter or shift return, you'll see that its values are printed. We also see list in the last lecture. Let us do a quick recap. Your list is a collection of numbers which are written in this fashion with opening and closing brackets separated by commas. You can also see the list of what it has. For example, it has 5 numbers. Next, let me introduce Numpy library. Numpy library is widely used in machine learning for doing many numerical operations, and we will also use in our first ML model as well. We will first create a 1D array, which you can directly create by passing 1D list, which has 5 elements. This creates our 1D array. You can also create a 2D array by passing 2 different lists separated by commas, like 1, 2, 3, and 4, 5, 6. Now we can do basic operations on these arrays. For example, we can do element-wise addition. So all of these elements of the array, we want to add, say, a number 10. We can do 11, 12, 13, 14, such as. In reality, we can do element-wise addition to all of these numbers, say a noise we want to add. And this is how we add a noise. We can also do element-wise multiplication, for example, of this 2D array. All of these elements we want to multiply by a number constant, say 2. Each of this number now turns into 1, 2, 3, becomes 2, 4, 6, and so on. Playing with numbers is fun, but we also want to plot them, we want to visualize them. That's where the matplot library comes into picture. You can easily use matplot by importing it, matplotlib.pyplot.splt. On Google Colab, these NumPy and matplot will directly work, and you don't have to install anything. For example, x and y we want to plot. These x and y are kind of representing lines, so that's why the plot looks straight. But what it is doing is we are doing a plot of this and a scatter plot of this. If you comment the plot, there's only the scatter plot which will only show the points. If you comment the scatter plot and only say the plot function, which actually shows only a line. So indirectly, the plot will connect all these individual district dots and show us as a line. Let us see both of them simultaneously, and it will tell us what the points are and how they are connected. Previous flow didn't show the X and Y axis, so you can actually put labels of points and lines and X and Y axes and give a title to the plot. Also, if you want to see the grids, say, this kind of looks a bit more professional, where we see where these grids are passing, where the points are lying, what is X axis, what is Y axis, and so on. Next, let us generate some random numbers using NumPy, and these are the numbers which we'll use to train our machine learning model. I'm using np.randomSeed. So this is to make sure that every time we run it, it creates same random numbers. We are passing it seed of 0. Further, we are creating 10 different random numbers here. This is the line which we are creating using X, and this is where we are doing element-wise multiplication and element-wise addition of the NumPy array. We are adding 4 to all the elements after multiplying them with 3. If you do that, the Y metric or Y array which is created, which we see here, looks like this. X and Y matrix are numbers. What actually they represent is a line. And let us plot the line and look into what it looks like. The X and Y, which we just created, these numbers, and we are also doing a scatter plot of them, assigning the axes and so on. It looks like the line looks beautiful. The points are plotted on it. In reality, this line is never this straight from the real data. So let us add some noise to it. I'm creating some random noise here, again using NumPy. This is creating 10 random points, and those noise is added with 0.1 contribution. Let us see how the scatter noise looks like. As you see, now the points are no more straight. And now let us look at how the line looks like with noise. If you do the line with noise, we'll see that the lines are going zigzag fashion. The reason being that they are no more straightly connected because it's a very noisy data. So there, let us not plot the line using X and Y now. Let us only look at them in a point fashion, then how they look like. After learning NumPy and Matplotlib, let us learn our first linear regression model using scikit-learn. We will again import our NumPy and Matplotlib libraries. The linear regression model is imported from scikit-learn, or it's called sklearn. Sklearn is also pre-installed on Jupyter Colab, which we are using. And these all functions will directly work for you all as well on the browser. Let us see what the X has. This is what we are going to give the model as input. And our goal is to learn Y, the prediction. As we know that X and Y represents a line, so model needs to learn this line, but Y is noisy. So model has to learn this line even in the presence of noise. Again, let us see what the data looks like before we proceed further. As you see, the data is a scatter plot with noises. The linear regression model is defined in this way. We are already imported it from the library. Model is equal to linear regression. Will create your model. Calling the fit function will learn the model from the data, fit on X and Y. Now let us see what the data has learned, what the model has learned from the data. There's intercept and slope. As you know, line is always represented by that. Let's see what the intercept and slope is. Intercept and slope are extracted from the model, as you see here, using the code using a dot notation. And we are also passing which elements we are extracting. As you see, the source of our data was Y is equal to 4 plus 3x. So our exact intercept was 4 and slope was 3. But from the data being noisy, we are able to learn intercept of 3.93. It should have been 4 and slope of 3.0, which is pretty close. Now let us make some new predictions. Since we have learned the model, we want to make prediction for the new data, 0 and 1. What is the value of this model? Our X new looks like this, and our predictions are shown here, 3.93 and 7.02. When X is 0 in this line, we should get around 4. We are getting 3.93, a little bit from the noisy data. And when X is 1, we should get 4 plus 3, 7. We are getting around 7.02. If we plot over everything together, this is over the data, and this is the prediction which we get from the model. So we are using it to plot the line directly between 2 points. This is what model has learned. As you see, data was noisy. The line is passing through the center of the model. This completes our first model training. We have learned the line from the noisy data. What we can do it, as you see, this line now gives us prediction for all X values, whether it's 0, 0.2, 0.6, and so on. Why we create models in machine learning is to get predictions at all of these unknown values for which we have no data. We only use data at this part and this part, but we are able to get interpolations at all other unknown points. I hope you all enjoyed it. I'll see you in the next video.